Hi, and welcome to a Regents Chemistry midterm review. Now, Regents Chemistry is the chemistry that is studied in the state of New York for high school students. If you are a high school student in another state, this should work very well for you as well. And what I've done is I put the topics typically we get through with the first half year of the course. If you haven't gotten to something, that's fine. You can just skip it. And if there's something in addition to that I'm not addressing in this video and you would like a review of that, then you just can add a comment below and I will get to it as soon as I can. Now, in doing this midterm review, I decided that I would go over the August 2024 Chemistry Regents exam questions that relate to these topics. And with that, let's get started. If you've never checked out my channel before, I have plenty of videos on the parts of the Regents exams, the past exams. I have YouTube shorts on all of the topics and different things you need to know. A lot of the beginning of the test and probably your midterm as well is vocabulary driven in chemistry. And then of course you have to be able to put pieces of the course together. You should have your chemistry reference tables out. You should have a calculator, a pen, and a piece of paper. If there's any vocabulary words you don't remember or don't recognize, if there's anything you know you need to go back and study further, you want to jot that down. Get the most out of this that you can. And with that, let's check out question 1. It says, which two particles each have a mass of approximately 1 atomic mass unit? In chemistry, for 1 atomic mass unit, that's a proton and a neutron. That's what gives an atom its mass. Electrons do have some mass, but it's about 1/2000th the mass of a proton or a neutron. So essentially, we set it at 0. The answer here then is going to be choice 4. You need to know your basic atomic structure. Let's go on to 2. As the energy in a hydrogen atom as the electron in a hydrogen atom gains energy and moves from the first shell to the third shell, the hydrogen atom becomes, well, you're not knocking an electron out here. An electron is moving from a lower energy level up to a higher energy level. That means we're going from all of the electrons at the lowest energy levels available, known as the ground state, and we have an atom now that has gone into the excited state. And that is going to be choice 1. When you have an ion is a charged atom, and that means either an electron or electrons have been knocked out of the atom, or the atom has taken electrons in. For number 3, which phase describes the protons and neutrons in atoms with 2 different isotopes of the same element? Once again, this first 3 questions, there's a lot of vocabulary here. You need to know the word isotopes. Isotopes, same number of protons, different number of neutrons. And that actually, right here, is choice 1. The atom's identity is based on the number of protons only, not the number of electrons and not the number of neutrons. You got to know isotope. Here is another vocabulary word where they don't use the word, but this question shows up all the time, and that's question 4. Which phrase compares the properties and molecular structure of oxygen, O2, and ozone, O3? These are known not as isotopes, but allotropes. Now, they'll never use the word allotropes. Now, that's how you spell it. It sounds like isotope, but it's with an A, not an I. You're going to have different properties because you're going to have a different structure. It's made up of the same atoms, oxygen atoms, but that's about it. So different properties, different structure, or choice 4. For number 5, which phrase describes the composition of a compound? Of course, you should remember you dealt with elements, compounds, and then mixtures. Those 3 you need to know the definitions and properties for, and here in question 5, that's exactly what we're looking at. If you have a compound, you're going to have elements that are chemically combined, and that is choice 2. For number 6, which quantity is conserved during all reactions? Actually, it's energy, mass, and charge, which is choice 3. Usually, this question with charge will show up when you do what's called redox or reduction oxidation or electrochemistry in the spring. Probably not going to see this question for a midterm. For question 7, you have a 5-gram sample of which substance contains metallic bonds. If you've gotten into bonding halfway through the course, then you know there are 3 types. Your covalent, that's non-metal, non-metal. Your ionic, metal, non-metal. And metallic, which is metal, metal. When you're dealing with metallic bonds, you're dealing with elements that are metals, and in this case, iron or Fe, which is choice 2. Don't get confused with choice 1. A capital C and a capital O is carbon monoxide. C and a lowercase o, that's cobalt, and that would have been a metallic bond. Again, question 7, choice 2. For number 8, when a cesium atom becomes a positive ion, there is a change in electron configuration and radius. Which statement describes this change? Cesium is becoming positive, and the only way it's going to become positive if it's losing electrons. If an atom loses electrons, the size of the atom now as an ion gets smaller. In other words, the radius decreases. So you're losing electrons to become positively charged. So it's a 2-for-1 type question, right? We're not gaining, so let's get rid of choices 1 and 2. We have an atom losing an electron, and the radius decreases, which is choice 4. For number 9, given the equation represented a reaction, I have 2 fluorine atoms coming together, and we have the diatomic fluoride molecule. Which statement describes the changes that occur during this reaction? A bond is definitely formed, and when bonds are formed, energy is released, and that is choice 2. If you break a bond, in other words, if we were going the opposite way, in breaking bonds, energy is absorbed. If you can't remember it, think of it this way. If something was going to happen and you were going to break your arm, energy would go into breaking your arm. Okay? And same thing with bonds. If we're going to break a bond, energy is going to go into breaking that bond. For question 10, which atom in the ground state has a stable valence electron configuration? Really, what they're asking you is which of these 4 choices is a noble gas? That's all the way over in column 18. They are the most stable elements, and helium has 2 valence electrons, and all the rest have 8. Let's check the periodic table. You go to the periodic table. Noble gases are here all the way over to the right, and you're going to see the answer, which is going to be radon. And that is choice 4. For 11, which term represents the strength of attraction that an atom has for the electrons in a chemical bond? This is another key vocabulary word. Just like isotope is, so is electronegativity. Make sure you know it. Backwards, forwards, sideways, you name it, electronegativity. For question 12, which phase describes a sample of sodium chloride? And the S in parentheses means it's a solid. If it's a solid, it's going to be a substance, in this case a compound, and it's going to have a constant composition and properties throughout, which is choice 3. If it's a mixture, then you're going to have variations in composition and properties. But based on the way it's shown here, it is a compound, and again, constant composition and properties throughout. Also with individual elements, constant composition and properties throughout. For 13, which substance contains only atoms with the same atomic number? That is going to be another way of saying, hey, which of these 4 choices is an element? Now, you might recognize, you might not yet, some of the compound names. Ammonia is NH3. The answer is selenium. We'll get back to that in a minute. Methane is CH4, and water is H2O. Your answer here can only be selenium. Now, I do want to show you something. Looking at the periodic table, of course, it's the periodic table of elements for a reason. These are all elements. But what you're looking at are the symbols and not the names. If you forgot the name of any element, then you're going to go to reference table S. Not only does it give you the element name and symbol, it gives you physical properties such as electronegativity values, ionization energies, atomic radius, melting point, boiling point, etc. Don't forget about the reference tables. Question 14, differences in which properties allow the separation of a mixture of 2-propanol and water by distillation. There are separation methods you need to know, and there's going to be a physical property that's going to go ahead and separate one substance from another. For distillation, that happens to be boiling point, choice 1. We're going to skip 15. We're going to 16, which term represents a form of energy. It is not temperature, it's thermal. Temperature is a measure of the kinetic energy of the particles that make up a substance. Be very careful. This is another vocabulary word where students sometimes forget. They think, oh, well, it's just how hot or cold something is. That's not just the definition. For example, let's look at question 17. Which sample of zinc has atoms with the highest average kinetic energy? Average kinetic energy means highest temperature. Forget about amounts. That doesn't matter. It's the highest temperature, which is choice 1. 18. With matter, you also have the gas phase and the gas laws. Probably, if I had to guess, is taught as a separate unit, but it's under matter and energy. Under which conditions will a real gas behave more like an ideal gas? No real gas is ideal. We simplify particles of a gas and we look at the properties and what affects gas behavior, specifically temperature, pressure, volume. Any gas is going to behave more like an ideal gas when you're dealing with high temperature and low pressure. So again, high temperature, low pressure, or we'll reverse it, low pressure, high temperature. So first of all, get rid of 1 and 2, and then it's high temperature, which is choice 3. For 19, according to kinetic molecular theory, the particles of an ideal gas. I mentioned it already, but an ideal gas does not exist. We have what's known as real gases, but an ideal gas follows these simplified rules in order for us to do our calculations, and that's under kinetic molecular theory, or KMT, might be referred to as by your teacher. So what we're saying is that, for example, an ideal gas, we're not worried about the volume that the actual gas particles take up in a container. We're also not going to worry about the fact that even if they are nonpolar molecules or atoms of a particular gas, that they're not going to, they would still have slight attractions, but we're going to ignore that. And that's actually our answer here. Have no attractive forces between them. Okay? So you have to go over all the different, I don't want to say rules, but all the different circumstances for what's called an ideal gas. Literally list them out and make sure you know them. Of which we're going to say that ideal gases, there's no attractive forces between the gas particles. All right, for question 20, a reaction between two different gases is most likely to occur when the colliding molecules have the proper orientation and sufficient energy. Now, this is part of the kinetics unit, which is in the spring. You don't have to worry about this now, nor are we going to worry about 21 or 22. They're going to be showing up in the spring. Okay, I'm just checking these over. And that gets us through the first part of the August 2024 Regents exam. We're moving on. And these are more multiple choice questions. And let's take a look. For 31, a student calculates the density of a sample of iron to be 7.57 grams per cubic centimeter based on table S. What is the percent error for the student's calculated density? All right, we're going to go to table S, and we also got to go to reference table T. And the reason why I say that is we want to look at the percent error mathematical formula. All right, here we are at reference table S. We're going down to iron, which is Fe. And as I mentioned before, you see you got your symbols and your names here. We need density. So the known value for the density of iron is 7.87. Well, what are we going to do with that? Let's go here and we'll check out the formula, percent error. Okay, the accepted value is the one off the table, which is 7.87. So accepted value, the true value, known value, that also goes in the denominator, 7.87. And now we have to put in the student value, 7.57. So it's 7.57 minus 7.87 divided by 7.87 times 100. When you're doing these calculations, I would highly recommend that you write them down and you use a calculator and take things in steps if you need to. Now, don't be afraid of the negative here. You can have a positive or a negative percent error. The way that we plugged it in according to their equation, we're going to have 0.3, a negative 0.3 actually, over 7.87 and then times 100. I'm going to plug it into my calculator. I don't know about you. And of course, when I do, I got to find my calculator on my phone. It's 0.3 divided by 7.87 and then times 100. It's going to be a negative 3.8%. And here it is, choice 3. Notice they're giving you a choice here. This is for the student that forgets you need to times by 100. But you're not going to be that student. You're going to do the work right next to the equation or rewrite the equation and put all the numbers in and then calculate your answer. All right, let's take a look at 32 based on table S. Which general trend is observed as the elements in group 17 are considered in order of increasing atomic number from fluorine to iodine? Well, it's real simple. We just got to do a little detective work here. Let's go for it. All right, first I'm stopping at the periodic table. We're going to look at fluorine, and we're going down to iodine. But we're looking at it now on reference table S. I'm going to go ahead and erase my iron from before, and we're looking for fluorine. Then we got chlorine. We have bromine, and then iodine. But we can work with these three. Iodine would just be on the next page. As far as first ionization energy, 1681. Then we have 1251 and 1140. So first ionization energy is decreasing as we go down. Electronegativity, you got your 4, you got your 3.2, you got your 3. Again, it's going down. Our melting points are going from 53 to 172. So those are going up. Our boiling points are 85, 239, and 332. They're going up. Our densities, fluorine is of course it's a gas, fluorine and chlorine. Okay, it's becoming more dense as we go up. And atomic radius, fluorine, of course, is the smallest at 60 ppm, then 100, and then 117. That's going up. All right, with this information now, let's go back to the choices. Back here at 32, it's not an increase in ionization energy. It's actually a decrease. Can't be that. It is choice 2, an increase in boiling point. The melting point is also increasing, and the density is also increasing. All you got to do is use the tables there. For 33, which type of chemical reaction is represented by this equation? There's basic ones you need to know, and here are the labels. Synthesis, decomp, single, and double replacement. For this example, I have an element and a compound, and then compound element. I start with 2 and I end with 2, and one of them is the individual element on both sides. That is single replacement. Make sure you go over how to identify these 4 types of reactions. For 34 at STP, which property can be used to differentiate a 2-gram sodium chloride solid sample from a 2-gram sample of silver chloride? Well, the masses are both 2 grams. That's not going to help. The phase, they're both solids. Temperature, they're at STP. The only thing it's going to be is solubility. Now, sodium chloride is soluble in water, and silver chloride is not. There is a reference table. Offhand, it's reference table F that looks at solubilities of salts, but you really didn't even have to do that. You could just do process of elimination and get the answer. All right, for 35, which particle model diagram represents a sample of neon at 35 K in 1 ATM? Neon is a noble gas. It's monatomic. In other words, it doesn't have to bond to itself to be stable. And of course, if it's a gas, the atoms are going to be spread far apart, which is choice 1. Now, going over these model diagrams, choice 2 would look like a solid. Choice 4 almost looks like a diatomic molecule. You see the 2 circles touching in a liquid phase, and choice 3 looks like a diatomic in a gas phase. Our answer here, though, is choice 1 for neon. For 36, which formula represents a molecule with the most polar bond? Well, with covalent bonding, which is your non-metal bonding, which these 4 choices are, you have polar and non-polar type bonds. Non-polar bonds are for your diatomic molecules, which is F2 and H2 is part of that group. So, the most polar bond here is going to be either HCl or HBr. And how do I determine that? It's going to be determined by electronegativity difference. That means we have to check out reference table S. What I did here is I just pulled out the electronegativities for hydrogen, chlorine, and bromine. Your HCl is going to have a more polar bond than HBr because look at the electronegativity difference. Cl is 3.2, hydrogen is 2.2. The difference is 1, right, absolute value-wise. For HBr, bromine is 3.0. So 3.0 minus 2.2 is 0.8. That makes HCl a more polar bond. That means we're checking out, or not checking out, we're circling choice 3. All right, for question 37, what is the amount of heat that must be absorbed to increase the temperature of a 130 gram sample of water from 20 degrees to 50 degrees? There are 3 heat equations on reference table T. And when you have a change in temperature, you're dealing with water as a liquid only. For that, let me go show you what I'm talking about with the reference table, and we'll come back. Here they are, the heat equations. Now we have water as only one phase. That's going to be Q is equal to MC delta T. And the specific heat capacity is going to be on the front of the reference table. And let me just show you this as well. If you were dealing with a heating curve, where are we on the curve? We would be here. We would be warming water. When you're on a plateau, that's a phase change, and you have no change in temperature in that case. This is for heat of fusion here, and this is for heat of vaporization. But again, we're right here for the question. Let's go back. Notice I wrote the equation down. I would always suggest you do the same. We're looking for the amount of heat, that's our Q. Our mass is 130 grams. Our C is our constant. That's specific heat capacity for water, and it's on the front of the reference table, table B, and it's 4.18 joules over grams degrees Celsius, but I don't have to worry about units here, so 4.18. And our delta T, we went from 20 to 50, so 50 minus 20 is 30. Now I'm going to multiply these together. Grab your calculator. I'm grabbing mine. I got 130 times 4.18 times 30, and I get an answer of 16,302. That's all well and good, but now we notice that we have our answers in scientific notation. Don't panic. It's not a problem. I'm going to take this big number, and I'm going to make the number in front smaller, or 1.6, and I'm moving the decimal 1, 2, 3, 4. That's 1.6 times 10 to the 4th joules, which is choice 2. All right, we are going to check out question 38 here. This is the last multiple choice question that is associated with the first half of the chem course. The other questions are the part B-2 and part C, which are the fill-in type questions. I'm going to do that in a separate video. I'm going to split it into part 1 and part 2. It's as important to go over questions where you have to provide the answer or show the calculation as much as practicing the multiple choice. Don't be one of those students that only looks at multiple choice. Any of the vocabulary words we went through today that you don't know, write them down and make sure you know them. Any of the calculations that you're not sure of, go back and do. There are plenty of questions. I'm sure your teacher's going to give you some review materials as well. Check out my other videos here on the site. Make sure you subscribe. And with that, let's check out question 38. We have a sealed rigid container that contains 50 milliliters of argon gas at 1 atmosphere and 273 Kelvin. A second sealed rigid container contains helium gas. Which conditions of volume, pressure, and temperature in the second cylinder would result in the number of helium atoms being equal to the number of argon atoms in the first cylinder? All right, let's draw ourselves a picture. Here's my argon, and here is my helium. Argon is 1 atm, 273, and let's see, what does it say? 50 mils. Well, what does the second one have to be so we have the same number of atoms? Well, first of all, they're both noble gases. You got to be careful. This would have been a tricky question if we were dealing with helium atoms and, let's say, the molecule, the molecule hydrogen molecules, because that's H2. The number of atoms, right? H2, you have two atoms of hydrogen for every one molecule. That would have been a little bit more difficult to check out. But here, these are both monatomic, so it's 1 for 1. So it's real simple here. We would want the same exact parameters. We want 50 mils we want ATM and 273, which sure enough is choice 2. Keep working hard. If you have any comments or questions, please go ahead and just add here to the video, and I'll get to them as soon as I can. Main thing is keep reviewing, keep studying, and keep up the good work.